Hello students, in this video I will go through exercise U5A02B, which is an exercise taken directly out of the Glencoe book from page 479 to 483 on solving similar triangles, solving for sides of similar triangles. Let's take a look. Question number 1 to 4, the instructions read, determine if the triangles are similar, and if so, write a similarity statement. Side angle side, side side side, or angle angle similarity. So let's take a look. So according to this, I immediately noticed I have two parallel lines here. Therefore, these angles are going to be congruent, and these angles are going to be congruent based on the alternate interior angle, right? So because of this, we can then say that these two triangles are going to be similar based on angle-angle theorem. Now we got to write a similarity statement. The similarity statement is triangle XYZ, and this part here is the tricky part. You do not say VWZ because all the angles on the other side of the similarity symbol there, they all have to correspond. So X will correspond with, is it V or is it W? It's got to correspond with W. Then Y will correspond with V, and Z will correspond with Z. So this is the similarity statement that they were looking for. Question 2. So here I'm not given any, I'm given a side angle side relationship here, but here I'm giving a side-side angle, which is not anything. So in order for me to determine whether or not these two triangles are actually similar, I need to find the third corresponding side, which is, this is 5 here. This is a 3, 4, 5 right triangle. And it just so happens that 6 and 10 here is a part of the 3, 4, 5 right triangle as well. This side here must be 8. Will the similarity statement hold true, right? So I can say 3 to 6. Is it corresponding to 4 to 8? Is it corresponding to 5 to 10? And yes, indeed, all these equal to 1/2. So I can say that triangle ABC is similar to triangle, and again, it's really important that the letters do correspond. So A will correspond with F, E will correspond with C. I'm sorry. Let me reread this. Let me see. B will correspond with D, and C will correspond with E, I believe. Yes. Yes. So here, this is the case because of side-side-side similarity. And again, if you're having difficulty recognizing how to write this out, okay, it is important for you to be able to sort of rearrange, right? This is why it's, it's important to be able to translate different objects through rigid motions. So if I take triangle ABC and I perform the following transformations to it, you can then see this is 3 and that's 4, and this is B and that's C, right? So all those things will line up. A corresponds with F, B corresponds with D, and C corresponds with E. Okay, moving on over here. 6, let's do the longest side here, which is 12. 12 corresponds with the longest side over there is 6. Will it be the same thing as 8 to, my apologies for these being so grainy and hard to read. I believe this is a 6, and I believe this is an 8. Okay, so will it correspond with 8 to 6? You can already see that they are not the same. Because of this, this is not similar. Okay, now we're going to compare the longest side, which is 20, to the longest side in the small triangle, which is 8. Is this going to hold true for 15 to 6 and 10 to 4? Well, 20 to 8, the greatest common factor is 4, so this will be 5 halves. Greatest common factor between 15 and 6 is 3, so it's going to be 5 halves again. Greatest common factor between 10 and 4 is, again, 5 to 2. So yes, this is going to be a side-side-side similarity. And we can say then JKL, triangle JKL is similar to triangle SQR. Okay? All right. Moving on, identify the similar triangles, find each measure. So I have 51 and this angle. So these two triangles are going to be similar because of angle-angle theorem. And we have to find out what is KL. So I can say x to 4 is to 15 to, I believe that is a 5. I believe that's a 5 here. Okay? So if that's the case, then I will end up with 12. X is equal to 12. Or KL is equal to 12. All right, moving on. Here, I have two right angles, so that's one angle, and it's sharing one angle there, so it's angle-angle theorem again. So then I can say 12 to 3 is to x to 5. Cross multiply both sides. I end up with x is equal to 20. I'm asked to find out what is VS, right? So VS is equal to 20. Okay. Next, determine if the triangles are similar. So let's see here. This side here, I believe that this is an 8, and this is a 3.2. So if I compare 8 to 8 plus 3.2, is this going to be the same as 5 to 7, 5 plus 2? Is this going to be the same thing as 10 to 14? So this right here is 5/7. This right here has a common factor of 5, and that reduces to 5/7. So that holds true. So what is tricky is this guy right here is 8 to 11.2, the same thing as 5/7. Well, if I take 8, 11.2 and multiply top and bottom by 5 and 5, I'll get 40 over 16. And 40 and 16 have a common factor of 8. I'm sorry, not 5 times 11.2 is not 16. That is 56. If I divide top and bottom by 8, I'll get 5 to 7. So yes, this indeed holds true. So we have a side-side-side similarity situation. So then we can say triangle WUV is similar to triangle XUZ. Okay, next. Nothing can really be said about this because we have no idea whether or not these are the same. We only have one angle that is going to be shared, so does not have to be similar. Okay, so here in this case, I have 38 and 38, so these angles here are 38 apiece. Again, I apologize for the grainy appearance. So those are 38. I have a large triangle. I'm just going to break this up. This is 17 and 10. And then I have a smaller triangle. This is 38. This is 8 and 9. So do I have a side angle side relationship here? Well, I can see that 10 to 17 is the same as 8 to 9. These are not the same, right? So these are not similar. Okay, and then moving on. Determine whether the triangles are similar, and if so, write a similarity statement. If not, what would be needed to show that the triangles are similar? So these angles are going to be congruent because of corresponding angles of parallel lines cut by transversal. So therefore, this is true. It is going to be similar because of angle-angle similarity. So triangle JKL is going to be similar to LJM. I'm sorry, JKL is similar to, not JKL. That's why I'm looking at it funny. JKP is going to be similar to JLM. Okay, next I have, I don't know this third side here. Okay. And if I knew this third side, then I can say, if I call that side length there x, if I set x to corresponding with 19, actually that's an 18, this is 18 here, x to 18 is to 2 to 12. If that third side was shown, okay, then, and then this guy over here is y, should be y to 4. If that's the case, then, okay, we would have enough information here to show, okay, that this is actually similar. So if that's the case, if I cross multiply with this guy, right, so I get 12x is equal to 36, x will equal to 3. And then if I cross multiply with this guy, I get y is equal to 8/12. And, sorry, y to 4 is to 2 to 12. I got it backwards. My apologies. So it should be 4 to y. I got it backwards, which is why I looked at it funny. So this should be 48 divided by 2. So would be 24. Okay? So if that's the case, if these sides here were true, then we would have a side-side-side similarity. Side-side-side similarity, or actually I should say, if this is true, then we would have a side-side-side similarity. Okay. Let's take a look at the next one. So this is 68. And this is 59. And if we look at this, 68 plus 47, what is that? 68 plus 47, that is 5. So I'm looking for 68 plus 47 is 115. Subtract that by 180, that's 65. Now, in order for these two triangles to be similar, I have to see whether or not this third angle here is actually going to be 65 or any of the other two. And I can clearly see already that this is 59 here and that's 47. The third angle will not be any of those. So this is not similar. Because the third angle here, if I take 47 plus 59, what would that be? That would be, let's see, 106. And then I would need 74. This would have to be 74, right? So not similar. Third angle does not form angle-angle relationship. Okay. Moving on. Identify the similar triangles, then find each measure. So here in this case, I know that this is going to be congruent to that because of vertical angles. So therefore, I do have angle-angle theorem. So I can say x over 4 is to 12 over 6. And 12 over 6 is equal to 2, so therefore x must equal to 8. So jk is equal to 8. Moving on, these are corresponding angles, and this is a angle that's equal to itself. So then I can say x over 12 is to 20 over 16. Cross multiply, I get 16x is equal to 12 times 20. So this is equal to 240. Divide both sides by 16. I end up with 15. And if QS is equal to 15, then ST is equal to 20 minus 15, which is 5. Okay, we need to find WZ and UZ. I notice that I have two triangles that are adjacent to one another. So these two triangles that are adjacent to one another are actually going to be similar because I have right angle in both of them, and I have this angle over here and this angle over here are congruent. So therefore, I can then solve for this. This is 32, this is 40. I can use Pythagorean theorem to solve for WU. WU squared is equal to 40 squared minus 32 squared. WU, if you solve this, turns out to be 24. So that's 24. So then I can set up the following. I can say W, U, Y is similar to Z, U, W, right? So then I can say that WZ over UZ is equal to WY over UW, or WU. No. Yes. Okay. WUZ to UZ, so hypotenuse to leg. WY hypotenuse to leg. Yes, that's it. Okay, so UZ, or WZ, is 3x minus 6. And UZ is x plus 6. WY is 40. And UW is 24. I noticed that 40 and 24 has a common factor of 8, so that becomes 5/3. If I cross multiply, I end up with 9x minus 18 is equal to 5x plus 30. Subtract both sides by 5x, I end up with 4x. Add 18 to both sides, I end up with 48. X will end up equaling to 12. Since x is equal to 12, I can then find WZ. WZ will therefore equal to 12 times 3, which is 36, minus 6 is 30, and UZ is equal to 18, because 12 plus 6. Okay, moving on. I need to find out what HK is. These two triangles are similar, so therefore I can say that triangle HJK will be similar to triangle NQP. So HJ is 4x plus 7 to HK, which is 6x minus 2. This is 6x minus 2. And this is 4x plus 7. Again, my apologies for these things not looking as clear as they really should be. And this is equivalent to NQ, which is 12. Right? HJ is to NQ. And HK is to NP. NP is 8. This guy here is 8. So I noticed that 12 and 8, they have a common factor of 4, so that reduces to 3 to 2. Cross multiply, I end up with 2 times 4x plus 7 is equal to 3 times 6x minus 2. Distribute the 3, I get 18x minus 6. Distribute the 2, I get 8x plus 14. Subtract 8x, I end up with 10x. So, add 6 to both sides, I end up with 20. Divide by 10, x is equal to 2. All right. Next, I have this is a right angle, and these two angles are congruent. So therefore, these angles over here are going to be congruent. So therefore, I can set up 2x plus 1, which is the hypotenuse, to the hypotenuse of the other triangle, which is 20. And it corresponds with 2x minus 1 to 12. I can cross multiply. 12 times 2x plus 1 is equal to 20 times 2x minus 1. Notice that 12 and 20 have a common factor of 4, so this would become 3 2x plus 1, and 5 2x minus 1. Why am I doing that? Just because it makes the computation just slightly easier. This becomes 6x plus 3 is equal to 10x minus 5. Subtract both sides by 10x, I end up with negative 4x. Subtract both sides by 3, I end up with negative 8. Divide by negative 4, I end up with x is equal to 2. So since x is equal to 2, I can then find out what dB is. dB is equal to 5. And CB is equal to 12 plus 2 times 2 minus 1. So that would be 3, which is 15. And the last question. All right. So I'm told that the angle measures that this angle over here is the same as this overall large angle over there. Again, my apologies for not making this clearer or because of the image quality there. And there's an angle over here that's being shared. So the small triangle here will be similar to the big triangle, overall big triangle. Okay, so if that's the case, then I can say, I'm going to break this up. So this is 7, this is 2x minus 2, 2x plus 4, and the other big triangle, I want to draw it like so. So this will be 7, and this will be 10, and that's all I know. Okay, I don't know that other long side. Okay, so again, this is GHO, this is GHO, and then this guy over here is GHJ. Okay, so I can then set up 10 over 7, or actually, yeah, I can do that. 10 over 7 is to 2x plus 4 over 2x minus 2. I can cross multiply, and I end up with, well, before I do, I notice that there's a common factor between 2x plus 4 and 2x minus 2. And if I divide both the top and bottom by 2, I'll end up with x plus 2 over x minus 1. See how it makes the computation just that much easier? Cross multiply, I end up with 10 times x minus 1 is equal to 7 times x plus 2. Distribute, 10x minus 10 is equal to 7x plus 4. Subtract both sides by 7x, I end up with 3x. Add 10 to both sides, I end up with 14. X will equal to 14 thirds. The question is, let me see here if I made a mistake here, because usually these numbers turn out to be whole integers, but there are occasions where it will not come out to be that, and that is perfectly fine actually. But let me see here, 2x plus 4 and 2x minus 2. Yes, this all appears to check out. 7x. This is 4. Oh, I did make a mistake. So I made the mistake here. It's not 7x plus 4, 7x plus 14. So if I subtract 7x from both sides, I end up with 3x. Add 10 to both sides, I end up with 24. Divide by 3 and end up with x is equal to 8. You see? Never hurts to go back and check. So x is equal to 8. If x is equal to 8, then CD or GD will equal to, oh, that's a D, not an O. Okay, so this guy, GD, will equal to 2 times 8, 16, minus 2 is 14. And DH will equal to 2 times 8 plus 4, so that's 20. And that's it.